Good morning, everyone. In the last video lecture regarding the hybridization, we have studied till now the case of sp, sp2, sp3, sp3d hybridization. Now we further move with the concept of hybridization and discuss the case of sp3d2 hybridization. In this hybridization, there is sp3d2, 1s, 3p, 2 d orbitals are mixed and to give 6 sp3d2 hybrid orbitals. In that case, in the case of the sp3d2 hybridization, we discuss the example of sf6. We discuss the example of sf6. sf6 generally oxygen, sulfur, oxygen, sulfur. ऑक्सीजन का एटॉमिक नंबर 8 है, इलेक्ट्रॉनिक कन्फिगरेशन 1s2, 2s2 और 2p4. And for sulfur, the electronic configuration, only the valence cell electronic configuration is 3s2, 3p4. Atomic number is 16, 1s2, 2s2, 2p6, 3s2, 3p4. This is the valence cell electronic configuration. 2 electron in the ground state s orbital and the 4 electron in the p orbital. 1, 2, 3, 4. Okay, but as you can see that in the sf6 6 fluorine atom have covalent bond with sulfur. So 6 unpaired electrons are required, and that this is only feasible when the one of the 3p electron and one of the 3s electron is excited to the 3d orbital, and this one is the dx square minus y square and dz square orbital in the case of the sp3d2 hybridization. Okay, so for the formation of the 6 covalent bond with sulfur fluorine atom, or we can say that for the sulfur atom have to be form 6 fluorine atom, 6 covalent bond with 6 fluorine atom. For that, sulfur need 6 unpaired electron. So when the fluorine atom started to approaching or started to form covalent bond with sulfur atom, the bond is break, and during that bond breaking, during that bond formation, the energy is lead, and that energy is absorbed by 3p electron, and that is excited to the 3d, and after some time the 3s electron is also excited to the 3d higher energy orbitals, and now there is an 6 unpaired electron, 1, 2, 3, 4, 5, 6. These 6 unpaired electron involves in the covalent bond formation and forms 6 covalent bond with 6 fluorine atom, 6 covalent bond with 6 fluorine atom. Okay, and also remember the d orbital involved in the bond formation is dx square minus y square and dz square orbitals. Okay, further s orbital 1s 3p and 2d dz square and second one is the dx square minus dy square. Combines to form 6 sp3d2 hybrid orbitals and have octahedral geometry. The four of the fluorine atom are on the square of the corner 1, 2, 3, 4, and 2 fluorine atom. One is above the square and one is below the square. Okay, the 6 fluorine atom are in the octahedral geometry and bond angle is 90 degree. Bond angle is 90 degree. All of these bond atoms are 90 degree. Further, this is the better representation of octahedral structure for 6 hexafluoride SF6. 6 sp3 d2 hybrid orbitals with 2p orbital of fluorine. This one is also the 2p. Bond angle is 90 degree and geometry is octahedral. sp3d2 sf6. Okay, so this is the case of sp3d2 hybridization and octahedral geometry. Bond angle is 90 degree and bond angle in between these is f1s f2. f1s f2 is 180 degree. Okay, and bond angle is f2s f3 is 90 degree. sp3 due to hybridization, all of this we can easily understand from that. So I hope you clearly understand the geometry of SF6 sp3d2 hybridization. So thank you so much.